What's up, mathematicians? Justin here, and today we're going to talk about the rules. And by the rules, I mean the rules for geometric constructions. So in the last lesson, I hope you had fun playing around with the tools, making some interesting and beautiful geometric constructions. But now it's time to get serious because we have a goal here, right? Our goal is to prove that the angle sum of a triangle is 180 degrees. We would also like to prove that similar triangles have proportional sides. Remember that without these facts, the angle sum of a triangle and the proportionality of similar triangles, many of our measurement tools, including trigonometry, will be lost. They rely on these facts. So our goal right now is to build up a system so that we can prove these facts and be confident in them. So let's start by looking at the rules for geometric constructions. Okay, so this is lesson 3.2, the rules, and I'm going to start a little bit down. I'm going to leave some space up here. It'll become apparent why later. So let's just start by listing the rules. What are the rules? And I've come up with 4 rules for geometric construction. So rule number 1 is you can draw a point anywhere. Rule number 2, remember to write these down. You can connect 2 points. You can connect 2 points with a line. So given 2 points, you can connect those 2 points with a line. And the tool for bringing that rule into reality is our straight edge. Rule number 3, you can make a line longer. Basically, if you have a line, you can extend it. You can make it longer. And rule number 4, you can draw a circle. Draw a circle centered at any point with any radius. Those are our 4 rules for geometric constructions. And let's think about these rules for a minute. I know we haven't really spent time working with them and experimenting with them, but just stop to think about these rules for just a minute here. And as you think about these rules, first of all, do you think they are powerful enough to prove that the angle sum of a triangle is 180 degrees? Can we use just these rules to prove that the angle sum of a triangle is 180 degrees? Furthermore, are these rules powerful enough to prove anything? What can you construct with these rules? Now, certainly, the question of whether things are provable, we'll think about that soon, but certainly it should be clear that we can construct things with these rules, right? If nothing else, we can construct 2 points, connect them with a line, and then draw a circle with that line as a radius. And finally, do we have any unstated assumptions? One of the important things in creating a solid, robust system is to be open and clear about all the things we're assuming and what all the rules of the game are. So are there any sort of unstated assumptions that you can sense here as we think about these rules? So yeah, let's go ahead and just leave it there for a moment and, see what you can come up with, especially that question of, are there unstated assumptions here? Think about that, maybe pause the video and try to write down any that you can come up with. Okay, welcome back. Let's introduce some of the concepts of axiomatic systems to what we have here in front of us. And so if you recall, in the last unit we talked a bit about axiomatic systems as being grounded or embedded in logic and language. So all of these things that we're doing rely on us being able to use logic and language. Sorry for that misspelling. Let me correct that. Logic and language. Okay, so now on this ground of logic and language, we have our foundation. And our foundation is going to include all these rules. It's kind of a tall foundation, so that might seem a little odd, but we have to have space to write all these things down, right? And I asked you a minute ago if there were any sort of unstated assumptions here, and we'll talk more about this as we go through the unit and the next few units about assumptions and being clear about them. But one assumption that might have come to you is this. As we read these rules, you can draw a point anywhere. Anywhere on what? You can connect any 2 points with a line. Where is this line? Where are these points? So one assumption that is in these rules somewhere is that we have some sort of space, that there's a space that exists. And for our purposes in this unit, that space is going to be a sheet of paper. So we are also assuming that we have a sheet of paper. So maybe we should add that to our ground. That seems like even more of an embedded thing than what we have here in the rules. So logic and language and a sheet of paper. Now keep in mind that a sheet of paper is two-dimensional if we think about it in terms of the perfect sense, right? It represents a two-dimensional thing, even though the sheet of paper, it technically has thickness, but the surface that we're writing on is basically a two-dimensional surface. Okay, so now we have our rules, we have our ground, and we want to see what we can build on this foundation. What structure are we capable of building, and how far can we build up? Can we build up to the angle sum of a triangle, or is this system not going to be powerful enough for that? In the next video, we will put our first brick on this system. Hope to see you then.